later absolute value inequalities. So here are the things you will need to do. You will first need to graph a line represented by the inequality. That is called your boundary. You will need to shade part of the graph with the solutions. And to do that, you can test true points for sure to know where you're supposed to shade. You can also, if it is in slope-intercept form, you can look at which way your inequality is pointing. If not, then your testing is the best way to go. You also, in this instance, which is already done for you, your boundary line is a dashed line or a dotted line, however you want to look at it, because it does not have the or equal to part. So for the example, we have a dashed boundary. So here's an example where we have to do the test a point because it is not in slope-intercept form. So we use the x and y intercept method. There's our x-intercept, which is 2, 0. Here's our y-intercept, which is 0, 1/2, and we graph those 2 points to get our line. And then we are going to test a point. This is all going to show up at once because of the way I have these notes done. So we will graph these 2 points and we will have our line, and then we will have shading on this side of the line. Because this is an inequality, it is not just a line, it is a line with shading because it represents the whole part of that coordinate plane, sometimes called a half plane, for the solution. Now to test a point, we need to know which part we have to shade. I like to use 0, 0. So 0, that will be the x value, and the y value will become 0 will be x, 0 will be y, and I will perform the math. So that will be 0 plus 4 times 0, which gives this whole side to be 0. And so I check and I go, is 0 greater than 2? No, it's not. That's false. That means here's my line when it is graphed. 0 is to the sort of left or below side. So that means I will not shade that part or to that side of the line which I graphed, which was my boundary. So I shade to the other side if that is my false test. So you don't shade to your false test. When I graph absolute value inequalities, I pretty much do the same thing. I have to graph my absolute value function. I need to shade part of the graph where the solutions are true, and I can test a point. Oh, this still has the line. That's funny. This particular example has a solid boundary for that particular absolute value. So this is a solid V. This is a different test. How funny. So let's graph this absolute value, y greater than 3 times the absolute value of x plus 1. We need to know where h and k are. So remember, h is inside your absolute value expression. K would be back here. Do I have a k? And what is your a value, which will make it either skinnier or wider. And then we will also test that point. So when we look at it, h was -1 inside here. Remember, it changes the sign. K, I had no k. And I had an a value of 3, which was sort of the slope. So it made it a skinnier V graph. And then when I tested my point, if I did 0, 0, because it doesn't end up being on that V graph, I have a 0 value for the y, and then I can put 0 in for the x, so I have 0 plus 1. Absolute value of that is just going to be 1. So then I have a 1 times 3, which is all my math over here. So is 0 greater than 3? Nope, so it's false. So I do not need to shade where this point is. So this is my false test. So here is my V. That 0, 0 where I tested came out false. So in this area where that point is, that was my false test. I don't want to shade that. So I shade, which ends up being inside my V. That is true. So that is the basics of absolute value and linear inequalities. And we will hit the highlights and make sure that you understand completely in class. Oh my gosh, where's my cursor?